everyone. We are here to present a final year project that is heart disease prediction model. I am Isha Shrivastava.
I am Amal Dubey.
As we know, in today's day and age, heart disease remains a critical health challenge influenced by several contemporary challenges like lifestyle changes, aging population, urbanization and stress, environmental and socio-economic factors, etc. While technology has brought about convenience, it also has brought the sedentary lifestyles. However, it also offers potential solutions through health monitoring devices, telemedicine, and personalized healthcare. The primary object of our project is to develop a machine learning based model to predict heart disease. This model will utilize patients' data, including demographic information like medical history, lifestyle, and clinical test results to accurately predict the likelihood of heart disease. By providing early warnings and risk assessments, the model aims to support healthcare providers in making informed decisions and encourage patients to adopt their healthier lifestyles. The benefits of our model are early detection, identifying individuals at high risk for heart diseases to before clinical symptoms manifest, allowing for a timely intervention and management, personalized medicine, tailoring prevention and treatment strategies to individual risk profiles, improving outcomes, preventive care, and resource optimizations. The methodology that we are going to use is going to be in four parts, that is data collection and pre-processing. Second would be feature selection and engineering. Third would be model training and validation. And fourth would be deployment. Further on that later. Basically, in this model, we are going to use three algorithms, namely KNN, SVM, and logistic regression. KNN stands for K nearest neighbor. It is the simplest algorithm which works incredibly in practice that stores all the available cases and classifies the new data of case based on a similar measure. K in the KNN algorithm denotes the number of nearest neighbor of the new points which needs to be predicted, which is generally 3 or 5. SVM. SVM stands for Support Vector Machine, works by finding the best possible boundary hyperplane that separates different classes in the given data. The hyperplane selected maximizes the distance between the closest data points from each class. Last one would be the logistic regression. It is a statistical method used for predicting binary outcomes, yes or no, true or false, etc., based on one or more variable inputs. It estimates the probability of the outcome based on the input variables and maps this probability onto a binary outcome using a function called logistic function.
Coming on to the second part of our model, which is data visualization. Data visualization aids in drawing out useful conclusions in sometimes graphical analysis, which helps us to draw out some useful conclusions. To identify relationships between different variables and in heart diseases, we can create a correlation heat map. It provides a color-coded matrix that depicts the correlation coefficients between the pairs of variables. The correlation heat map displays the correlation coefficients between various variables in the dataset. Each cell represents the strength and direction of the correlation. Positive values indicate a positive correlation, while negative values denote a negative correlation. This visualization helps us to identify which factors have a significant impact on heart disease and which not. From this heat map, we can understand that blood pressure levels with age has a positive value, which means it has a positive correlation. And hence we can conclude that this has a person having this correlation will have a greater risk of having a heart disease. Similarly, blood pressure also has positive correlations with cholesterol, thallium levels, etc. So we can conclude that the person having such values will have a greater risk of heart disease. Next up, we have a scatter plot showcasing the relationship between a person's age and corresponding to its sex and the presence and absence of heart disease. The y-axis represents the age range of the patients, while the x-axis has the presence and absence of heart disease between 0 and 1 for both the sexes. Each point represents a patient the age of the patient, and the x-axis represents their sex. This visualization allows us to observe any patterns or trends between the two parameters we have undertaken, which can provide insights into its impact on the presence of heart disease. In the second graph, we can see the cholesterol as the count, that is the presence or absence of heart disease are often associated with with the gender of a person. We can visualize the distribution of the same among patients with and without heart diseases using a bar plot. The box plot represents the distribution of cholesterol levels on the y-axis based on the gender of the person on the x-axis, and hereby the presence or absence of the heart disease. This visualization helps us to compare the cholesterol levels between the patients of the different genders with and without heart disease. Interface and performances are as follows. We have used the Python language for this, and which is built, and the Jupyter notebook was used for all the building of the model. The accuracies of our used models are as follows, with KNN giving an accuracy of 75% and the respective time taken. SVM with an accuracy of 83.95%. Logistic regression gave the highest accuracy, about 90.74%.
Okay, so now the project flowchart, which basically describes the data flow of the data flow in the model. So in the start, we will collect the heart disease data set that will have the patient's data, like their age, their sex, their medical history, any do they have blood pressure, all of these, etc. And then they extract the significant variables, as in the significant variables that are required for the prediction. They mean we may not need all the data for all the prediction. And then we would be pre-processing data, as in removing the null points that are present in the data set. Then comes the data visualization part, which was the graphs that Amal explained earlier. Then we would analyze the data using the three algorithms, namely KNN, SVM, and logistic regression, respectively. We used three of them because we started with the KNN and we wanted to increase the accuracy. We moved further to SVM, and then we moved lastly to logistic regression, which was giving uh, a greater amount of accuracy. And then we would test performance, like we would train the data, and now is the time to check if our model is actually working or not. And according to its performance, we would then deploy the data, which would take the patient's data and classify how much of a risk it has of heart disease or not. Okay, the data that we have taken from the Kaggle repository for, for our model. We then pre-processed it, as I said, to remove any null points or stuff. Then we moved to the classification models, which were the models algorithms that I described earlier. Then we moved to the feature selection, which was basically which one to choose to move further with our models, which features to choose. Then came our model's results, how accurately is it working or not. And finally, the conclusion that logistic regression had the most amount of accuracy that we came with.
The technology and the requirements that were used are as follows. Jupyter Notebook, which is used to create interactive notebook documents that can contain live code, equations, visualizations, media, and other data analysis components. It is often used by programmers, data scientists, and students to document and demonstrate coding workflows. Python. Python is a computer programming language often used to build websites and software, automate tasks, and analyze data. sklearn is a Python library which contains a lot of efficient tools for machine learning and statistical modeling, including classification, regression, and clustering and dimensionality reduction. Similarly, all these libraries belong to Python. NumPy, which is used to perform the computational tasks in data analysis, removing outliers and in a skewed data set, which could here, if they were not removed, they could affect the accuracy. Matplotlib, Seaborn, these are the libraries which help to visualize the data for plotting graphs and etc. Pandas is also used to importing the data set and for the application of other libraries for data analysis. Concluding, the proposed system is UI based, user friendly, scalable, and reliable. The proposed working model can also help in reducing treatment costs by providing initial diagnostics in time. The model can also serve the purpose of training tool for medical students and will be a soft diagnostic tool available for physicians and cardiologists. General physicians can utilize this tool for initial diagnosis of cardio patients. There are many possible improvements that could be explored to improve the scalability and accuracy of this prediction system. We are also looking forward to increasing its usability and feasibility. By developing this model into an fully integrated website or a medical app, which could be used by medical fields to perform
Professionals,
the
yes.
health diagnosis and all. So, with this, we would like to end this presentation. Thank you.
Thank you.